All right, we're good to go. So let's present. We have to make sure the slides are on the other screen. So we need to move this window to your other screen.
Okay, how do I full screen for this?
To move it to the projector.
Okay, let me just wait. If I just pull this, will the screen share thing still work?
Yeah, I think so. No, it looks like it didn't. Because you made a new window.
Okay, should I stop this or should I just put it back?
If you stop it, you can't start it again.
Oh, no, wait, don't close it. Just drag it back.
Yeah. But you have it open here. Oh no, this is it.
Yeah.
Okay, so.
Yeah, I can drag the whole thing.
Yeah, drag the whole thing over and then.
Oh, where'd it go? I did not make it over. There you go. Okay.
And then I think use this window. All right, cool. I think we're good.
All right. Let's see. I don't have any presenter notes, so I don't know if I actually want to use this window.
That's okay.
Yeah. Is there another window I could use?
No, unfortunately not.
Okay. I want to make it bigger, like this part, so I can like look at the slide, but I don't know how.
Unfortunately not.
Oh frick.
Is there anything?
I don't have any speaker notes.
Yeah, well, this is the best we can do.
Can I just do a regular view?
That would require you to switch your display settings.
The mirroring.
Yeah, you can do mirroring. How about you do that? I'll do distance.
Okay.
All right, hello everyone. Sorry for the slow start. We're trying to go through some technical difficulties with the new laptop. So as you know, your final is going to be Thursday from 2 to 5 p.m. I've sent out I posted room assignments on our Data 8 website, but I'm planning to make another Piazza email blast to everyone at sometime this afternoon with all the final details. You will be allowed 2 handwritten cheat sheets on the final, and you will also be given the midterm reference sheet and the final reference sheet. You can find those sheets on the resources page of our class website. And the project 3 is due Wednesday at midnight. Wednesday, right? Can we move it to Thursday? It was Wednesday. So it's due Wednesday at midnight. Make sure you have that in. But you'll probably want to get working on it sooner rather than later because the final is coming up pretty soon. So lectures today, tomorrow, and the day after that will be final review. Today we're going to be talking about programming tables and histograms with the wonderful Nancy Wang. Woohoo! And I think that's all I got, so I'll let her take it away.
Okay. Let's turn this on. Oh, this was muted the whole time. Hello? 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 Is this working? Yeah. Okay, cool. All right. Hi, everyone. So we're going to be presenting on programming tables and histograms today. Our first topic, we are going to skip control statements, actually, and we're going to go to functions. So let's talk briefly about functions. Functions encapsulate code, so you can use it over and over again without rewriting it. So when you write a function, you define the function name, and then you define 0 or more arguments. And then within the body of the function, Within the body of the function, you have some code that you want, and then there's a return statement at the end, usually. And that body of the function can be used over and over again whenever you call the function by the function name. So that's kind of the intuition behind why you want to define functions. Instead of rewriting the body over and over again, you can just define it once and then reuse it, calling it by that name. So all functions have return values, including the ones provided for you to use with tables and arrays. You can write a function without a return value, but that's usually not the case. You usually want a return value. All the functions that we give you to use with tables and arrays have return values, like .where. .where returns a table, so we can call .scatter afterwards. But if you call .scatter first, scatter returns none, so we can't call where after it because there's nothing to call where on. Does that make sense to everyone? Yeah, so that's why there's a certain order you have to do your function calls in when you're working with arrays and tables. All right, so let's do a quick question right now. Try writing a function. I want a function that called hungry adder that does the following. It takes 2 numbers as arguments, it adds them together, returns the value, and then it also prints the string, thanks for feeding me those tasty numbers. All right, so let's take about 4 or 5 minutes to work on this question. And yeah. So if you have paper, you can pull out paper, or you can just like type it into whatever text editor you have on your laptop. Yeah, question?
You want us to add them together then print, or do you want to print?
It doesn't matter what order you do them in, as long as it prints out the string and then returns the value. So building, oops, I muted this, I think. Building off of what you said, Kevin, it doesn't matter what order you write code in within a function. When you write a function, your function is defined by like the inputs and the output. So you give it something and output something. So whatever you do inside the body, whatever order you do it in doesn't matter. Like how you do it doesn't matter, as long as the output is like what we specified it to be. Okay. So let's take about 1 more minute, just in case. Sam, can you dim the light a little bit? It's like shining in my face and it's kind of hot. Okay, thanks. All right, so let's go over the answer. Does anyone have a solution for this question and wants to share it? Yeah, go for it.
Define hungry adder, parentheses, x comma y has 2 numbers that it takes in.
Mm-hmm.
I set the sum into a variable called sum, so sum equals x plus y. Then I did print thanks for giving me those tasty numbers, then return sum.
Okay, so why did you print the string out before you return the value?
Because I figured out if I just put a return before the print, the function would just halt at the return statement.
And you would never get to the print, right?
Right.
Yeah, that's exactly right. Good job. So this is our version of it. We didn't do sum like you did, but that's totally okay as well. So one thing to keep in mind is that you need to print out thanks for feeding me those tasty numbers before you return x plus y. Once you hit the return statement, the function will end. So if you put the print statement below, like in this case, the print statement will never be reached, and you won't ever print out that string, and your function would be incorrect. Yeah, good job. All right, so let's move on to arrays and tables. I'm going to hand off to Sam, and he's going to talk about some theoretical stuff about arrays and tables, and as well as go over some table functions with you guys. Yeah. So do you just want me to stand here the whole time?
Yeah.
Okay.
All right, so we're not going to switch mics because it's too much work. So Nancy's just going to stand here and be my mic. All right, so let's talk about arrays and tables. So arrays just contain values. They're useful because you can work with multiple values at once. As we've seen multiple times throughout this entire class, I hope you know what an array is, because if you don't, I would ask where you've been. So to make an array, you use make array, and you put stuff in it. Here, this notation is kind of old, so these slides are a little bit old. Normally, we don't see these brackets here. You can use it either way. So make array, you can just pass in 1, 2, 3, and it'll work. It'll create an array with 1, 2, 3. Okay, so tables are just a collection of arrays. That's one way to think about it. Each column of a table is an array, and we grab out those arrays by using table.column with the label of the column. So you should make sure you know the distinction between table.select and table.column. So table.column gives back the column of the table as an array. Table.select, if you call select and select out one column of a table, it will return to you a new table with just one column. So the types of things are different when you use table.column and table.select. You should really be sure that you know the difference between those two so you don't get confused. So table.column grabs back the array, makes a new table. So the thing about tables is each column needs to be the same type. So here we have decimals and strings and integers. But we can also view tables, as we discussed in class before, as a collection of rows. So you can look at it, you can slice it vertically in terms of each individual column, or you can grab out horizontal slices of rows and manipulate a table in that way. In particular, if you use table.where, table.where works on the rows of a table. It says, grab out only the rows where the predicate is true for the particular value in the column. I think you guys have seen enough of that, so I don't have to go over it too much. But as an example, if I did this table.where longitude is equal to 32, then it looks like only this row and this row would appear in my final resulting table. Table.where, used to filter out rows. So I'm going to go straight into table.join. So we use table.join to combine two tables together. So whenever you see two tables and you know you need to combine them together or use information from both of them in some way, you almost certainly want to use table.join. I'm going to point out to you some gotchas when it comes to joining. Okay, so here's the way it works. So if I have a table, I have a column in that first table that I want to join with a column in the second table. This is the syntax I want to use. And the way it works is this. So if I call sp16.join, I notice that these two columns are the same or have similar values. Okay. So these two columns look like they could be mashed together. Because they can be matched together, I can use sp16.join, and I want to join the class column of this table with the course column of the professor's table. So I call sp16.class prof_course, and that will join the two tables together. Now I want you to know that the order in which you join is important. Okay, let's take a look at these two outputs. So you notice how the only difference between these two, the only difference between these two is that I've switched prof.join sp16 with sp16.join prof. So I'm switching the order of the join, but the output of the table is different. And that's because of the way join works. The way that the join works for our tables is that it takes the first table, goes through every single value in this column, and finds the matching row from the other table to join on. So the way, if I call it like sp16.join, what it's going to do is it's going to go to the first row, say, okay, my class column is CS61A. Look in my prof table for CS61A, the professor as the fourth column here. Go to my next row, CS61A. Match the same row in the prof table, grab the hill finger, put it in there. Oops. Then go to data 8, find a matching row, find the data 8, put it there. So that's why the first result, so it's kind of a weird order here. This is the same line of code as at the end of the slide in the previous slide. So that's why I have 3 rows here. But if I flip the order of the join, watch what happens. If I do prof, oh my goodness, prof.join sp16, it's going to go course 61A, look in my sp16 table, and grab the first row that matches it. So I'm going to grab student ID and GPA into the new table, and then go to my next row, data 8, find the row that matches data 8, pull in the values there for a new row. And because I'm going through these values like that, if I do prof.join, I'm only going to get 2 rows in my resulting table, whereas if I do sp16.join, I'll get 3 rows. Questions about that? Kevin?
So there are multiple matches, it always just picks out the first row instead of all of them?
That's right. So if there are multiple matches, the way that our join works is that it will pick out the first match. So if you go into future courses, there's many different types of joins, and all of them behave like some different way. But for our class, this is the way that you should know that our join works. So you should know there's more ways that join works, but you should know that ours works this way. Any questions? All right, so let's talk about grouping. So grouping works like this, and you've seen this a bunch of times. I want to reiterate to you kind of like the metric that you can use to decide when to use group and when to use some other function. So as I described before, sometimes you want to go through like categories in a table. Generally speaking, like one way you can do that is if you find yourself doing like table.where multiple times in a row on the same column, chances are pretty good you want to use group instead. Okay, so if you look at a problem and you don't know whether to use group or not, and you're like, okay, how can I solve this? Sometimes like you're like, okay, I can use a for loop and then do like table.where a couple of times to get back groupings of the column. If you find yourself wanting to do table.where multiple times in the same column, chances are very good you want to use group instead. Okay, and so grouping, what it does is it takes the column, grabs all the unique values in the column, and groups them together according to the function that we define here. If we call group with, so if we don't call group with the function here, it will just produce a new table with one extra column called the count, which counts up how many times each value in this column appear. If we pass in a function, then what happens is the values of the other columns in that table will get passed into your function. So the function that you pass into group, you should know that the type of thing that you pass in to this function, when you define this function, it needs to be able to take in an array. It's going to take in an array and output something else. But the important part is that you have to give it an array here. Otherwise, it won't work properly with group. All right. So try this out. What would happen if I call sp16.dropClass.group student ID with np.mean? Go ahead. Okay, so that's kind of a warm-up. Let's go through it step by step. So if we drop the class, we only have student ID and GPA. If we group by the student ID, then we look for all the unique student IDs in the table and group them together. So it looks like 1, 2, 3, 4 is by itself, and then 5, 6, 7, 8 appears 2 times. So there's a group here of size 2. And then we call np.mean on all the values in each group. So the class is gone, so we only have GPA. The mean of 3.3 is 3.3. So we get student ID 1, 2, 3, 4 with 3.3. Oops. Oh, there we go. And then we have these two rows for 5, 6, 7, 8. If we group them together with the mean, then we'll take the mean of 3.0 and 4.0 and get a mean of 3.5. Any questions about that? Alrighty. So let's talk about grouping with multiple columns. The way that grouping with multiple columns works is that when you group with one column, you look for the unique values in that one particular column. When you group by multiple columns, you look at unique pairs of values in 2 columns or unique triplets of values in 3 columns, so on and so forth. So if I group by column 1 and column 2, I'm going to get all the unique pairs in both columns and create a group out of each one of those. The function here also takes in an array. Okay, so the function here also you want to take in an array, and then we get called like before on each group. The way the groups are formed are different with multiple columns. In particular, you can use grouping with multiple columns to think about pivot. So if you find yourself wanting to use grouping with multiple columns, but you want the format of your table to look different, that tends to be when you want to use pivot. Let me just go through all of these. Okay. So pivot is kind of like grouping with multiple columns. The way it works is these 2 arguments are the 2 columns you're grouping on. The third argument is the values to aggregate, or another column in your table that you want to group on. Sorry, that you want to like aggregate together in your final result. And your fourth argument is a function here. So if I go and compare these two, all right. So let's say I group on both student ID and the class. and I want to find the mean GPA for each student ID class pair, I would group on both of these. So I'll get every unique pair, 1, 2, 3, 4, CS61A, 5, 6, 7, 8, CS61A. So if I group by multiple columns, if I pass in an array of student ID and class instead of just student ID, I'm going to get 3 rows in my resulting table instead of 2. I'm going to get 3 rows, and these are all going to be the same. So if I call np.mean on this particular table, then I'm going to get the mean GPA is just going to be the numbers here, because each group here, each row here was its own group. I could, in theory, use pivot. So if I used pivot and pivoted these 2 columns, I would get student IDs on the left and classes on as the columns of my new table. And my GPA values, if I pass those in as the values of my pivot function, the GPA values would be the values of that pivot table. Okay. So it's kind of hard to explain. It's kind of hard to explain in slides, but if you're still unclear about how it works, I suggest you create that table with the students and GPAs. Okay. So if we pivot student ID in class, what we're going to get is classes on the left, the unique classes, the unique student IDs on top, so 1, 2, 3, 4, 5, 6, 7, 8. And by default, pivot counts up the number of rows that match the groups. So there was one row that had both 1, 2, 3, 4 and CS61A. There was one row that had both 5, 6, 7, 8 and CS61A. There were 0 rows that had student ID 1, 2, 3, 4 and data 8, etc. Okay. So if I call student ID, class GPA, and the mean, what you'll see here is the same groupings, same columns, same rows. And instead of taking the number of rows that matched each group, I'm going to take the GPA column and take the mean of those GPAs. So you notice here that the numbers here don't change, and that's because each row in my table was its own group. If I happen to change this student ID 5, 6, 7, 8 to 1, 2, 3, 4 and took the mean, what I would get here is 1, 2, 3, 4 and CS61A. The mean of that would be both these GPAs averaged together. All right. So try this out.
Yeah, so we have a couple of practice questions about table functions and stuff like that. So go ahead and try out both A and B. So A is write a line of code that computes the average of the amount column, and B is write a line of code that returns a table with only the products that are above average. Yeah. So why don't we take, let's see, 6 minutes to do this? 6 or 7 minutes. Yeah. All right. Does anyone need any more time on this question? Okay. Does anyone want to share their answer to this question? Both A and B. Yeah, in the back. Yep, for the first one. Great. And then for the second one? Okay, yeah, great. Yeah, that works. Good job. So part A, you just want to find the average. So you take np.average and you find the column amount. For part B, it can do exactly what you said and use what you did in part A. So you can store that in whatever variable you want. And then the second one, you want to use .where because you want a table with only the products that are above average, and the products are the rows. So you use .where to select just the rows that you want for your table in part B. Yeah. So let's skip to the yeah. So take a look at the answers. Yeah. So for the first one, it's np.mean exports.column amount. For the second one, it's exports.where amount are above. And then in this case, we didn't save it, but you could totally save what you did in part A and reuse it. np.mean exports.column amount. Keep in mind that I said above average, so that would be r above and not r above and equal to. Okay, let's work on part C and D of this question. And let's see, it'll take about 5 minutes to do this. Yeah. So go for it. Yeah. Let's say not inclusive. Yeah, for part D, between 50 and 100 million, so not inclusive of 50 and 100. All right, let's go over this question. So would anyone like to share their answers for C or D? Preferably, let's do both at the same time. Yeah, I know you know the answer. I'll let someone else answer. Yeah. What do you have?
Imports amount greater than 1. Apply the countdown 0 from the array and check if it's greater than 0.
Okay, so you want to do np.count non-zero on the column, let's see, amount. Yeah, and then amount greater than 1. Okay, yeah, that works. And then for part D?
Exports where amount are between 50 and 100.
Yeah, great.
And some rows divided by exports rows.
Okay, so you found a new table with just the rows between 50 and 100 million. You found the number of rows in that divided by the number of rows in the original table. Yeah, good job. So those were both correct for C and D. You can actually do C in many different ways. Yeah, this is one way that they did it. So on the solutions, we did exports.sort amount, .com amount, .item 0 less than 1. So they sorted it and they checked if, let's see, any export are less than 1 million. So when they sort it by amount, that goes descending equals true. The largest element is at the top. If the largest element is less than 1, then nothing is, then everything is less than 1. But if the largest element is greater than 1, then this is true. So this is one way to do it. Your way would also work. And for part D, we have exports.where amount are between 50 and 100 .num rows divided by exports.num rows. So this is exactly how you did it. Yeah, there are a lot of different ways to do part C. You can also like do a .where and then find if the number of rows remaining is less than is greater than 1, stuff like that. Yeah. All right, let's go to practice problem 2. So Alice wants to pick out a new TV show to watch and decides to use some data she found online about various TV shows to make a decision. The table of TV shows she used is called TV_shows, and each row corresponds to a unique show. The first 6 rows of the table are shown above. Let's move on. There are initially too many options to choose from, so Alice decides to filter the table to only include shows that satisfy both of the following decisions. It has at least an 8.0 rating and has at least 6 seasons, so she's looking for long shows. Write an expression that will filter TV shows such that only the rows satisfying both the above conditions will be included. So this is your exercise. Let's take 2 or 3 minutes to work on this. Go ahead. So I'm pretty sure House of Cards is more than 4 seasons by now, but I don't think it has 6 seasons yet. This is outdated. All right, let's go over A. So does anyone want to share their solution for part A? Yes, Alan?
Yeah, TV shows that where, for instance, ratings are above or equal to 8.0, that where it is the column 2.
Okay, that works.
Are above 5.
R above 5. Okay, yeah, so R above 5 is at least 6. Great. Could you do it the other way around as well? So if you filtered it by seasons first and then rating, would that also work?
Yeah.
Yeah, okay, good job. So let's go to solution. So this is part A. TV shows dot where rating are above or equal to 8, where number of seasons are above or equal to 6. Yeah, so because we want both of these things to be true, you can filter it by rating first or seasons first or the other way around. It doesn't really matter as long as you do both. All right, let's move on to part B. Alice realizes that she doesn't even know what type of show she wants to watch, so she decides to look at what genres people seem to like the best. First, write an expression that will create a table with the average rating for each genre and assign it to the variable shows grouped by genre. Then use this table to find the genre with the highest average rating and assign it to the variable highest rated genre. So this is a two-part question. Why don't we take 5 minutes to work on it, and we'll see if that's enough time. right. Does anyone need any more time on this question? No? All right. So does anyone want to share their solution for part B? It's a two-part question. Yeah.
Shows that group genre, comma, P.me.
Okay. For shows grouped by genre, right? Great. And then for the second part?
Shows group by genre, sort, rating, descending equals true.
Mm-hmm. And then what you want to find the genre with the highest average rating and assign it to the variable highest rated genre. So one more step after that.
So dot column and dot item 0.
We want the highest to find the genre. So not the name of the TV show, but the genre of the TV show. Yeah, so it would be dot genre and then dot item 0. Great. Yeah, so let's take a look at the solutions. For part B, the first one is shows grouped by genre equals TV shows dot group genre and p.mean. So not only will this average the ratings, it'll actually also try to average all the other columns as well. So it'll try to average number of seasons, name, premiere year. Yeah, question?
Yeah, so for convenience, should we take the rating column and genre column first?
Yeah, so if you don't want to see all the other columns, you can select out the 2 columns that you want and then just call dot group after that. You can also just ignore the other columns because a lot of them will be blank because it'll be trying to average like strings and that doesn't really work out. But if you want it to like look clean, you can take out the other columns first and then just have the columns that you want.
So I just have another question. If we don't take those 2 columns, I don't know where the average rating column would be in my resulting table. What's the name of that column?
Yeah, so it'll always be the name of the original column, and then it'll say, I think, either average or mean afterwards. But yeah, if you want to like index it by like the column index instead of the name, then you can definitely just take out the 2 columns that you want, and it'll be the 3rd column. So that's another way to do it. You can also just leave it like this and then print out the table, look at it, and then find which column you want. Either way works. And then the second part, highest rated genre equals shows grouped by genre dot sort rating mean descending equals true dot column genre dot item 0. So that'll give you the genre with the highest average rating. Yeah. Any questions about this one? Yeah.
What is the automatic value for descending? Is it true or false?
Automatically, it's descending equals true. Yeah. So if you don't put any, it's false. Oh. It's ascending order. Okay. Yeah. So if you don't put descending equals true, it'll automatically give you ascending order. So smallest first. Yeah. Okay. Yeah, question?
How do you know the name of the column? It's not like the second answer, like rating mean.
Yeah, so it'll just take the original name of the column, which is rating, and then if you do np.mean, it'll just stick mean at the end. Yeah, if you're not completely sure, you can just print out the table and then look at like visually what the column is called. But a general rule of thumb is like if you don't put anything and it does count, it'll say ratings count or it'll say rating count. If you do np.mean, it'll put rating mean.
Yeah. Underscore, just space.
Yeah, just space. Any other questions? All right, let's move on to part C. So in addition to looking at the ratings of TV shows classified by genre, Alice also cares about how old the show is, so since she doesn't want to watch a show where she doesn't recognize any of the actors and actresses. Write an expression to help Alice create a pivot table where the rows correspond to whether or not the show premiered after 2008, the columns correspond to the genre of the show, and the values in the table are the average rating of shows corresponding to each row. This is a little bit more complicated. They want you to create a pivot table instead of grouping it. So let's take about 3 or 4 minutes to work on this question. Yeah, so one thing to keep in mind when you're using the pivot function is that the first argument you pass in will create the columns of your new table, and the second argument will create the rows. So the order in which you pass them in will change what your table looks like. Oh, it is 12. All right, let's finish this question real quick, and then I will talk very briefly about histograms if we have time, or should we just? Yeah, okay. Yeah, so right now? Okay, yeah, so we're out of time. Let's just go over the answer for this one. So, yeah, sorry. The answer is TV shows with column after 2008, comma, TV shows column premiere year greater than 2008 pivot. Yeah, it's long. So let's do the pivot part first. The pivot part is, let's see. With column, yeah, 2008. Yeah, so you add a column called after 2008 that has true or false values. And then after that, you do .pivot, which you want genres in the columns, and then after 2008 in the rows. You want the numbers in the cells to be the rating, so that's your fourth argument. And you want to aggregate these values with mean, so that's input.mean. I know I went through that kind of fast. If you're confused, I highly recommend actually trying out pivot in Jupyter notebooks until you familiarize yourself with what they look like. I think that's the best way to learn these. And yeah, we are out of time. There are a couple slides on histograms at the end along with the fall 2016 question. So these slides will be posted. If you want to look at them, they will be online. And yeah, thank you guys for coming. Sorry we ran over time, but yeah. And we have office hours today at the regular times, and lab section will also be office hours. So if you have any questions, come in and we can help you out. Yeah. Thank you for coming. Sorry for going over time. Yes.